Assalamualaikum. We are from Group N. Today we present about our topic. The topic is capacitor and inductor in DC-DC converter. My name is Ahmad Farooq Kashabi Ruzali. My partner is Muhammad Anik Shazwan bin Omar and Muhammad Ajwad bin Tajul Shikin. So we will proceed to the first slide.
Ibrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Shazwan and my ID number is TG22083. Okay, let's start with PWM. If you have a source and let's say it's DC and it is turned on and off periodically, you will get a PWM signal. PWM means pulse with modulation. The amount of time of digital signal is in active state relative to the period of a signal is called duty cycle. If the switch is in for a long duration, a duty cycle increase, while if it's in a short time, we call it duty cycle decrease. Now, if you calculate the average of a cycle with duty cycle 50%, it will be half of the input voltage. Okay, let's say you have a 10-volt DC from supply. Now we reduce to 5 volt with just a switch. For efficiency, we will replace the switch with MOSFET that act as an electrical switch, and this MOSFET is controlled by PWM signal. But this PWM signal still has high voltage peak. So to smoothen it, we put an inductor. An inductor wants to keep current constant to itself. For that, it will constantly change the voltage across itself. As the switch closes, the current starts to flow. To resist this, the inductor drops the voltage at the end to 0, creating equal and opposite voltage of battery. This is possible due to magnetic field, which are generated in the inductor, but it can resist it for a long time. Thus, the current starts to flowing, and the voltage at the other end just now start to rising. This will make the inductor store energy in its magnetic field. After some time, the inductor will stabilize and the inductor will act as a closed switch, allowing maximum amount of current to flow. Now, when you open the switch, there is no source to supply current and voltage to the load. But as you know, the current in the inductor cannot change instantly. Hence, the inductor acts as an battery, supplying current, but it slowly runs out energy. As the end inductor, which is close to the battery, accumulates electron, it creates a very high voltage, negative voltage. Thus, we add a Schottky diode to allow a path for the electron. That's all for me. Thank you.
Okay, my name is Muhammad Ajwad. I will be presenting for part 3, which is frequency. So let's start. First one, how to frequency manipulate voltage. Okay, so the first part is the voltage load still high voltage spike, hence we increase the PWM signal. So the high voltage spike, we need to increase the PWM signal from the circuit. Okay, for the second one, the amount of increase is depend until the current and the voltage is stable. When we increase the current and the voltage, at the same time we need stable too. The third one is tools. This is why switch mode power supply using high frequency. Switch mode power supply in the circuit, they are using a high frequency to stable the voltage and the current. So next, frequency of DC to DC converter. The frequency of a DC to DC converter is the rate at which it switches the input voltage on and off to produce the desired output voltage level. The choice of frequency depends on the type of the converter, the desired efficiency, and the size and cost of the components required for the circuit. Okay, that's a summary for me. Thank you.
Bismillahirrahmanirrahim. Part 4, capacitor. How is capacitor work? The first phase, to further smoothen the voltage, we add capacitor in parallel. A capacitor wants to keep current to itself that will charge current to phase 2. To resist current by supply, the capacitor flows current to itself, raising the other terminal to equal to the supply voltage. The third phase, after some time, the plate of the capacitor gets fully charged. There is no current flow, and the capacitor now acts as an open switch. Then, when you open the switch, there is no source to supply the voltage. This voltage start falling, but as you know, the capacitor cannot charge, and then the capacitor now acts as a battery.
So I will be presenting for the circuit. Okay, so as we can see here, this is the circuit for DC to DC converter. At the left, we have the DC voltage, which I set to 12 volt, and the inductor I set to 180 microfarad. And then we have the voltage control SPST. Clock voltage I set to 5 volt and 50 kilohertz. And next we have capacitor, which I set to 33 microfarad. And the last one is the resistor, which I set to R load, resistor load. Okay, every end of it I put the ground. This is a type of connector. Okay, so to check the graph, so this is the graph, which, as we can see here, is the voltage spike high, and then it suddenly slowly turns down. It's decreasing. That's for my conclusion. So thank you.